for this example, we are not using numbers anymore. We are using numbers and variables, which are letters. And most people get a little scared when they see letters. They're not quite sure what to do with them. But you'll realize you do the exact same thing you would with numbers. So looking back at the previous example, our first term, I'm going to call all these with different colors. So our first term, blue, we want to multiply xy cubed over 3 cubed. Just distributed through. Same with this, x plus y squared over 2 squared, because you want to distribute the exponent to each the top and the bottom. So the numerator and the denominator. Minus. And now we're going to have another rule. Our rule is, if you look at the first example we did, we're given that x squared equals x times x. But what happens if you're given x squared squared? Well, that equals x squared times x squared. So that's one result we're going to have to use. Another result that we're going to have to use is that x to the a times x to the b equals x to the a plus b. Sorry, that's a b. So as long as it has the same base, so the same variable, the same number, you are able to add the exponents. But we're not quite there yet. We have one more thing we need to use. Looking off at the 1, x squared all squared will equal x squared times x squared, or x to the a to the b would equal x to the a times b. So we're going to use those 3 examples in order to solve the fraction in green. So minus x squared y squared z cubed all squared over 4 squared. So the blue one is easy. X cubed y cubed, because you can distribute it straight through the bracket, over 3 cubed, which would be 3 times 3, which is 9, times 3, which is 27. I suggest starting to get the easier ones down to memory, maybe the square root of all, and at least the cubed root of the first 5 digits or so, up to 5 times 5 times 5, which is 125. Once you have those, anything higher, most likely you'll have the option of using a calculator. If not, they are not too hard to find out. And then plus, now we have to square a binomial. So if you look at the video on Pascal's triangle, you'll know how the coefficients work. Or you can go x squared plus 2xy plus y squared, because it's the square of the first one plus the square of the second one plus the first times the second times 2. That's just a little trick when you're doing binomials squared. And then 2 times 2 is 4. And now we get to use our third rule down here in order to make sense of what's going on in the numerator of the green one. So x squared squared would be x 2 times 2, or 4. Y squared squared would be y to the 4th. And z cubed squared would be z 3 times 2, which would be z 6, all over 16. So now we're looking and we're trying, now we just need to combine these fractions before we're able to turn them into a single, now we need to combine these fractions in order to turn them into a single fraction. So first I'm going to deal with the 4 and the 16. So I'm leaving the x cubed, y cubed to the 27 alone. Plus, and I'm multiplying now the top and the bottom of the red by 4. And that's so I can have both of them over 16. And I left that 4 in red just so you can understand what I did, because I'm going to have to now distribute the 4 through each. Four x squared plus 8xy plus 4y squared minus x 4y 4 z6 all over 16. And now we need to combine 16 and 27. So the quickest way to do it would be, I'm going to write the numbers that I multiply in yellow. 16 times x cubed y cubed plus 27 times 4x squared plus 8xy plus 4y squared minus x 4y 4z6 all over 27 times 16, which would equal 16x cubed y cubed. Because remember, you're multiplying the 16 by the invisible 1. You're not multiplying, so you only need to have the 116 in there. You don't need to have 16 in there twice. Plus 27 times 4. 108 x squared plus 216 xy plus 108 y squared minus 27 x4 y4 z6 all over 27 times 16, which is 432. And now the last thing to do in this would be to combine your like terms. So we look at it, do we have any more x cubes, y cubes? So do we have any more x cubed, y cubes? The answer, no. Do we have any more single x's? No. Do we have any more xy's? No. And do we have any more y squareds? No. Do we have any more x fourths, y fourths, z to the 6th? No. So therefore that is our final answer. Our final answer doesn't look very pretty, but if you were to have to sub in numbers to it, this would be what you'd want to end with.